Now we're ready to solve all kinds of tricky problems like we have on this worksheet, 18.3. They're actually not going to be tricky for us at all. Before we get started on this worksheet, let's write down the important stuff that we have. So we have E cell is cat minus an. We also want to remember red cat. That helps us remember that the reduction is taking place at the cathode. And we also want to remember oil rig. That helps us remember oxidation is the one where electrons are lost as products. And we also want to remember, most important, E cell always, no matter what, always positive. So first question, what is the voltage of a cell made from copper and lead electrodes with 1 molar copper 2 ion and 1 molar lead 2 ion solutions? So this isn't even giving us a reaction. Like, we don't even have an equation here. We don't have any hints at all about which one is the oxidation and which one is the reduction. And we don't even need those hints. We know that one of our half reactions is copper and copper 2+, and we know that our other half reaction is lead and lead 2+. So our first thing is to go find the voltages of those half reactions. We're going to go look for them in our table. We have our table alphabetically, and the copper keeps coming up over and over again, so we already have that one highlighted. The copper 2+ is 0.3419. 0.3419 volts. Now we need to go find our lead and lead 2+ voltage. Lead starts with a P. Lead, we're looking for lead and lead 2+. You always want to make sure with these metals, make sure that you're double checking the charge and that you're finding the right half reaction. Negative 0.1262. Negative 0.1262 volts. So now we're ready to plug into E cell, cathode minus anode. And you might be saying to yourself, but wait, we don't know which one is the cathode, so we don't know which one comes first in the equation. Well, there's only two options here. So it's either going to be that the copper is the cathode, in which case it's 0.3419 minus negative 0.1262. That's one option. Or our other option is that lead is our cathode, in which case it would be negative 0.1262 minus 0.3419. And I've told you, and I promise, that when you do this type of calculation, only one of these versions of E cell is going to give you a positive number. One will give you a positive number, one will give you a negative number. I can see that this one is going to give me a negative number, which means it's not correct. We don't need to know which one is the cathode. All that we need to know is that E cell is always positive. So the voltage works out to be 0.3419 plus 0.1262, not very many volts, 0.4681. See, that's not so bad. Let's try another one. A voltaic cell is powered by the following reaction. Write a balanced equation for the half reaction that takes place at the cathode and the half reaction that takes place at the anode, and calculate the voltage of the cell. So this does look a little bit trickier. And there's a lot of stuff going on here. What I want to do is start by identifying my half reaction. So I've got copper 2+ going to copper 1+. So I have a copper 2+, copper 1+ half reaction. And then my other half reaction is hydrogen and hydroxide making water. So I have H2, OH minus, and H2O. That one's going to be a little bit trickier for us to look for on the table. Let's go find the copper one first. Copper, we're looking for copper 2+ and 1+. So at least we have a different copper this time. And it looks like our copper reaction that we want is right here. It has the 2+ and the 1+ ion, and so that is 0.153. 0.153. And then our other one, now this one's going to be harder because hydrogen and oxygen, not sure if we're going to find that in the H's or if we're going to find that in the O's. Let's go look. And what are we closer to? We're closer to, so here is H2O, hydrogen, and hydroxide. We lucked out. We just happened to find it right there. It's right in front of us, so that worked out pretty well. So this one is negative 0.8277. Negative 0.8277. So our first job is to calculate, well, the first thing that I want to do is calculate the voltage, because that to me is a lot easier to do. When I'm calculating the voltage, my options are going to be 0.153 minus negative 0.8277, or the other way around, negative 0.8277 minus 0.153. I'm not even going to write that down because I can see that what I have already written is going to give me a positive number. And I've told you, you're only going to get a positive number one way. So if you happen to get a positive number on the first try, that means that you got it right on the first try. So the voltage of our cell is 0.9807 volts. And now we want a balanced equation for the half reaction that's taking place at the cathode. Well, we can figure out which is which because we have correctly identified the order in the E-cell reaction. We know that E-cell is cathode minus anode. And for our half reaction, the cathode has to be the 0.153. The cathode has to be this copper system right here. So I know that the cathode half reaction, now this time we want it to be balanced, is going to be, I'm going to erase my highlights off of the equation. My cathode reaction is going to be the copper and the copper, 2Cu2+ aqueous, and 2Cu+ aqueous. And I've got to fill those electrons in. Where do the electrons go? Now you've learned how to figure out where the electrons go. Find the side that has the higher charge, add electrons to bring its charge down to match the other side, the lower side. So I did that there. If you are struggling still with figuring out where the electrodes go, or the electrons go, I'm going to show you an even easier way to do it with the next one. So we said the anode, from this, looking back at our E-cell, we said that the anode has to be the negative 0.8277 volts. The negative 0.8277 volts is the hydrogen OH minus H2O reaction. So let's say that we were just really struggling, not feeling confident about writing this half reaction. So here's what we can do. We can go to the table, go back to our table of half reactions, because guess what? In this table, they are all written and balanced for us. All of them, all that hard work that you did learning how to write and balance these half reactions, they're there. There they are. And so all that we have to do is copy it. 2H2O plus 2 electrons, blah, 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 blah. 2H2O plus 2 electrons makes H2 plus 2OH minus. Oh, but wait. We do have to be a little bit careful. We have to use our brains a little bit. The H2 and OH minus are on the left side of the equation for us in this particular system. So we've just got to get that turned around. H2H2O and 2 electrons. So you keep in mind that in that data table, everything is being written as a reduction. It's all already balanced. All that you have to do is turn the equation, the oxidation equation around, and you'll be good to go. Let's try it again. Let's see what's going on down here. A galvanic cell is designed using these two half reactions here, calculate the voltage of the cell, and write a balanced equation for the reduction, the oxidation, and the overall reaction. So first thing we're going to do is calculate the voltage of the cell. The voltage of the cell is going to be cathode minus anode, and our two potentials are given to us here. So one option is going to be negative 0.13 minus positive 0.771, and we can see that that's going to give us a negative voltage, so that can't be right. So that means we got to try it the other way. E cell is 0.771 minus negative 0.13. The voltage for this always has to be positive. The electrons are always going to move in the positive direction no matter how you set it up. The voltage is 0.901 volts. So that's the first part of the question. Then it wants to know the oxidation and the reduction half reactions. We're going to figure out which is which from our correct E cell calculation. So we know E cell is cathode minus anode. The cathode is the 0.771. So this is the cathode right here. Is the cathode reduction or oxidation? Remember our friend red cat. So the cathode is reduction. Remember oil rig. Reduction is gain, adding electrons. In the reduction reaction, electrons are being added, so they are on the left-hand side of the equation. So is this equation written correctly? Now that we know it's a reduction and we know the electrons should be on the right side, we can see that this equation, the one that's in blue, is good to go. This is our reduction. It is already written correctly. It is already balanced. It is perfect the way that it is. Let's move on to the oxidation. From the E cell equation, we know that the anode is negative 0.13 volts. So we know that this reaction right here is taking place at the anode. We know that the anode is the oxidation because it is not a red cat. We know that oxidation is when electrons are being lost or produced. In this particular half reactions, we are seeing electrons on the left-hand side of the arrow, which is not consistent with oxidation. All that means is that we're looking at the oxidation reaction backwards. Everything that's on the left-hand side of the arrow actually belongs on the right-hand side. And everything that's on the right-hand side actually belongs over here on the left. So for the oxidation reaction, what we have to do, all we have to do is just turn it around. CrOH3 solid plus 5OH minus makes CrO4 2 minus. I'm running out of room, so I'm going to leave out the states. 4 H2O and 3 electrons. So these two are the balanced equations for the reduction and the oxidation. And the last thing this problem asks us to do is to write the overall reaction. We're going to combine the overall reactions like we did when we learned how to balance equations. Before we combine the overall reaction, we have to make sure that the electrons have the same stoichiometric coefficient for both half reaction. They don't right now. We only have one electron in the reduction reaction, so we need to multiply everything in the reduction reaction by 3 so that it matches the oxidation reaction. And our overall reaction is going to be 3 Fe3 plus, again I'm going to leave the states out, plus 3 electrons, those are the reactants from the reduction, plus CrOH3 plus 5 OH minus. The products are 3 Fe2 plus CrO4 2 minus, 4H2O, and 3 electrons. We can cancel out the electrons. That's the only thing we can cancel out. There is our overall reaction. We have one more, just like this, same type of problem. So we get to practice it again. 2 half reactions, calculate the voltage, write out the half reaction for the reduction and for the oxidation, and write the overall equation. So first thing that we're going to do is use the voltages to calculate E cell, knowing that E cell has to be positive. I'm just going to try the first one, 1.23 minus 1.359. Before I do the math on that, I can see that that's going to give me a negative number, so I know that that is not correct. That's not the correct way to calculate it. So now I'm going to do it the other way, and I know that this way is going to be right. Only one way will give me a positive number. One way will give me a negative number. 1.359 minus 1.23 volts. 1.359 minus 1.23 is going to be a very small amount of volts, 0.129. So there is the calculated voltage for the cell. Second thing we have to do is write out our half reactions. Because we have correctly calculated E cell, we know the cathode and the anode. We know the cathode is the half reaction with 1.59 volts, right here. That's our cathode. And we know that the anode is the one with 1.23 volts, so this is our anode. So let's make a note over here. This is our cathode, or that's the reaction taking place at the cathode. This is the reaction taking place at the anode. The cathode is supposed to be the reduction reaction. And the reduction reaction is the one where we are gaining electrons, where electrons are the reactant. So looking at our cathode reaction and where are the electrons in this reaction, they're on the left-hand side, so that's good. This is written in the correct order. Our anode is our oxidation reaction. Oxidation is loss, so in an oxidation reaction, the electrons need to be on the product side. And in this reaction right now, the electrons are on the wrong side. So we need to take this whole equation and turn it around so that our electrons are on the correct side. So our oxidation half reaction is actually 2H2O makes O2 plus 4H plus 4 electrons. And again, I'm leaving out states just to save space. So when we're being asked to write the half reactions, here's the half reaction for oxidation, and here's the half reaction for reduction. It was already good when it was given to us, so we didn't have to rewrite it. And the last thing that we need to do is combine these two half reactions together. Before we combine, we have to make sure that the number of electrons in each half reaction is matching. The reduction half reaction only has 2 electrons in it, which means we need to multiply everything in this reaction by 2 so that both of the reactions have 4 electrons. Now we're ready to combine 2Cl2 plus 4 electrons plus 2H2O makes 4Cl minus plus O2 plus 4H plus and 4E minus, and we can cancel out our electrons but nothing else, and this is our overall reaction.